Welcome to the session on circles. A circle in geometry is a simple closed curve formed by all points in a plane at a fixed distance called radius from a given point called center. Circles play a foundational role in geometry and have many important properties, formulas, and related concepts. In ninth class, we have already covered some of the concepts of circles such as chord, segment, sector, arc, circumference, and area. Now, here in this session, we are going to cover the relation between a line and a circle, leading to three concepts like non-intersecting line, explained in figure a tangent, figure B, and a secant as shown in figure C. So, in figure A, you can see it is non-intersecting line because the line is not touching the circle at all. Therefore, a non-intersecting line will not touch circle and thus has no common point between the line and the circle. Now, a tangent touches the circle at only one point called the point of contact. As shown in figure B, it is touching at a single point. So, it is tangentially touching and progressing without intersecting circle at no other points. So, a tangent touches the circle at only one point called the point of contact. Therefore, it has only one common point with the circle, and the third thing is a secant. As shown in figure C, you are able to identify that this line is intersecting the circle at two given points. And interestingly, the portion captured by the circle of this line is called chord. So, a secant passes through the circle, intersecting the circle at 2 points. The portion of secant within the circle is called chord. Thus, a secant and circle share 2 points in common. Yeah, here one more interesting thing about a chord is from center, of the circle, if I drop a perpendicular onto this chord, yes, that exactly bisects the perpendicular line, exactly bisects the given chord AB into two equal halves. If M is the point of foot of the perpendicular, then AM equal to BM. So, this concept we are going to apply in the problems that we are going to discuss in the circle's second part. Yes. Now, back to the text. The portion of secant within the circle is called a chord, and thus a secant and circle share 2 points in common. So far it's clear, right? Now, at any given point on a circle, there can exist only one tangent line. There can't be two tangent lines at a given point on a circle. So that is very clear. Yeah, you can try if you can draw two tangents at a given point. Yeah, just you can experiment. Okay, now so it is not possible, right? So now only one tangent can be drawn at one point on a circle. But how many points are there on circle's circumference? Naturally, it is infinite points. Therefore, a circle will have infinite number of tangents, but each one is unique at a given point. Now, how many tangents can be drawn to a circle? The answer is as many points are there on the circle circumference, that is infinity. So, infinite number of tangents can be drawn. Okay. Now, yeah, you can see one more important thing. A tangent can be viewed as a secant where the end points of chord merge into a single point called the point of contact. So I have followed this. Here I have drawn a diagram adjacent to this, a circle, a secant is drawn. If secant gradually moves outward, it will be shown as that dashed line where A and B slowly merge into point called P. So A will gradually come here, here, and then finally it joins P. B also will merge with P. Therefore, A and B together they merge at the point of contact and making that secant as tangent. Hope the point is clear. Okay. Now we move on to the next point. Tangents drawn at the end points of any diameter of the circle will be parallel to each other. Yeah, how? Naturally, you can see I have taken a circle, drawn a diameter. Okay, so I have drawn two tangents. So they have to be parallel to each other. How to prove that? The proof is simple. Diameter is a line and tangent T1 is another line. You know, at the point of contact, the radius line is always perpendicular to the given tangent line. So, a single line is perpendicular to two different lines. That indicates they have to be parallel to each other. They have to be parallel to each other. Then only a single line can be perpendicular to both the lines. Therefore, they are parallel. So, T1 and T2 are parallel to each other. Yes, that's how it is proved. Now, coming to theorem 1, a tangent is perpendicular to the radius passing through the point of contact. Yeah, just now we have covered that. So, we have applied this particular theorem. A tangent is perpendicular to the radius passing through the point of contact. Yes. So, this line is perpendicular to this and also similar to the other side on T2. Fine. So, that is proved. Now, coming to the next point. From a given point, we can draw two tangents or one tangent or no tangents depending on whether the point is external or on the circle or internal to the circle respectively. I'll again repeat this. From a given point, we can draw two tangents or one tangent or no tangents depending upon whether the point is external or on the circle or internal to the circle respectively. That means what it means, if the point is external, we can draw two tangents from that point onto a circle. If the point itself is on the line, on the circumference line, then naturally only one tangent can be drawn at that point. That point itself will become the point of contact. Okay, and the third one is the point is lying within the circle. So if the point is lying within the circle, how can we draw a tangent? It is not possible. So what does it mean? No tangent can be drawn if the point is internal. So that's the meaning of this particular statement. Now coming to the final one of the concepts. From a given point P onto a circle, if I can draw two tangents just now we discussed. So let these two tangents meet the circle at two different points A and B. Then PA is called the length of the tangent. So from any external point P, if we draw two tangents onto a circle where the points of contact are A and B, then PA and PB are called the lengths of tangents. What is called? PA and PB are called lengths of the tangent. PA is the length of tangent, PB is length of another tangent. Okay, but we have PA equal to PB. That means both the lengths of tangents from a given point to a given circle will be equal. So this point is well explained. By taking the statement PA equal to PB, the lengths will be equal. So PA and PB are equal. Fine. So with this we end the session and we meet in session 2 of this circle with more practical examples with all the exercise questions. Thank you.